Many students think redox balancing is hard because the equations look messy. But in acidic solution, there is actually a fixed order you can follow every time. In this video, I'll show the half equation method step by step so it stops feeling random. A half equation shows only one side of a redox process. Instead of trying to balance the whole reaction at once, we focus on just one change first. In particular, we track the atom whose oxidation state changes, because that is the atom being oxidized or reduced. Once that part is balanced, we can then deal with oxygen, hydrogen, and finally charge. This is the method I want you to remember. First, balance the atom whose oxidation state changes. Then balance oxygen using water. After that, balance hydrogen using hydrogen ions. Finally, balance the overall charge using electrons. The biggest mistake students make is doing these steps in the wrong order. Let's start with a very simple example. Iron changes from +3 to +2. There is no oxygen and no hydrogen involved here. So the only thing we need to balance is charge. The left side is 1 unit more positive. So we add 1 electron to the left. That gives us a balanced half equation. Now, let's try a more important redox half equation. Permanganate ion changes to manganese 2+ ion in acidic solution. This is a classic example because it forces us to balance oxygen, hydrogen, and charge in the correct order. First, balance the atom whose oxidation state changes. Here, manganese is already balanced because there is 1 manganese on each side. Next, balance oxygen using water. There are 4 oxygens on the left, so I add 4 water molecules to the right. Now, look at hydrogen. On the right, 4 water molecules contain 8 hydrogen atoms altogether. Since we are in acidic solution, we balance hydrogen using hydrogen ions. So, I add 8 hydrogen ions to the left. Now we balance charge. The left side has an overall charge of +7 because +8 plus -1 equal to +7. The right side has an overall charge of +2. To make both sides equal, I add 5 electrons to the left side. That lowers the left side from +7 to +2. Now both the atoms and the charge are balanced. This also makes chemical sense. In permanganate ion MnO₄-, manganese has oxidation state of +7. In manganese 2+ ion, it becomes +2. The oxidation state decreases. So this is reduction. Reduction means gain of electrons. That is why the electrons appear on the left-hand side. So the balanced half equation is permanganate ion plus 8 hydrogen ions plus 5 electrons gives manganese 2+ ion plus 4 water molecules. The H+ suggests that we have an acidic solution. This is the pattern you want to get comfortable with. If redox balancing feels confusing, it is usually because the order has been mixed up. Do not start with electrons, meaning avoid balancing charge before atoms. Don't put electrons in too early. Do not balance hydrogen before oxygen. And remember, in acidic solution, hydrogen is balanced using H+. plus ions, not hydroxide OH minus ions. Here is the whole method again. Balance the redox active atom first, then oxygen with water, hydrogen with hydrogen ions, and finally charge with electrons. Once you trust this order, redox half equations becomes much more manageable.